Hello, my name is Carl Vincent Rubio, and this is my video assignment on the mesh and nodal analysis. So, uh, in this video assignment, we are asked to solve this circuit using mesh analysis. So, um, as you can see, this is our circuit here. Okay, our assumed direction is clockwise. Okay, and I put numbers here 1, 2, and 3 to indicate that this is mesh number 1, mesh number 2, and mesh number 3. So we are going to find the IA, I1, IB, I2, and I3. So basically we're going to find all of these current. So we have the given here. So the first thing that we're going to do is to apply KVL at mesh number 1. So again, this is clockwise, so we are going to enter the voltage. We're going to exit on the positive side, so that is positive E sub A. Okay. The current is in the same direction as the assumed. The current flows in the same direction as the assumed direction, so it's going to be negative. So here we go, negative IA RA, and then in this one. Okay, so in the R2, in this resistor, there are two currents that is being applied in this resistor. So it's I sub A and I sub 1. So I sub A follows the assumed direction, so it's negative. Okay, so we're going to put R2, okay, and we're going to distribute R2 into these values. Okay, so negative R2, positive IA, so that if it gets distributed, it becomes negative IA R2, which is what we want, because again, it follows the direction, and minus I1, because if we distribute this one, it becomes positive I1 R2, which is what we want, because I1 opposes the direction of our assumed direction, so it's going to be positive. Okay, so we're going to substitute the values. Okay, EA is 24, RA is 1, R2, okay, distributed, so R2 is 12, 12 IA, and 12 I1. Okay, we have 2 IA, so we're going to combine those. So we have negative 13 IA plus 12 I1. Okay, and the 24 gets the 24 gets transferred on the other side. Okay, so it's going to be negative. So we don't want we're going to divide both sides by negative 1. So we're going to have this one, which is our equation number 1. Okay, now we have the equation number 1. We're going to apply KVL at mesh number 2. Okay, so input the values in number 2. We have 3 resistors. Okay, and this is our assumed direction. So basically, we're just going to write all of them and divide them by the current, so that it gets distributed. And then plus IAR2. Okay, this is IAR2. Its direction is here, and our assumed direction is clockwise. So it opposes, IA opposes the direction. Okay, it's going to meet here, so that means it's going to be positive, plus IAR2. Okay, and then plus IBR3, okay, because it's the same thing here. As this one goes here, as I1 goes here, IB goes here, so it's going to meet. So that's going to be positive as well. Okay, so we're going to input the values. So negative 24, R1, R2, and R3. We're going to sum this. So R1 is 4, R2 is 12, R3 is 8. So that is going to be 24. Okay. R2 is 12, and R3 is 8. So we have this one. we're going to simplify. Okay, we can stop here, or you can divide both sides by -1. It depends on you, but okay, it's the same. But in my case, I use this one. Okay, so now let's continue. We are going to find the KVL. We're going to apply KVL at mesh number 3. Okay, this one. So again, it goes in here. Okay, in R3 there are 2 currents. So we have this one. Okay, R3. No, no. In this one we have 2 resistors. So again, we're going to just like what we did here. We added all of the resistors and multiplied it by its current. So here we go, R3 and RB. Okay, multiplied by IB. Okay, plus I1 R3. Okay, which is in this one because there is also current going in here, and our assumed current is going in here, so it's going to meet again. So that is positive I1 R3 minus EB. Okay, because our current goes here, it enters the positive side and exits the negative side. So that means our EB here is negative. So we're going to input the values R3 plus RB. R3 is 8, RB is 2, so that is 10, negative 10, plus R3 is 8, here we go, 8, and EB is, E sub B is 28. Okay, so we're going to transpose 28, so we have this one. This is our equation number 3. Okay, now we're going to input these in the calculator with, we're going to use elimination with these equations, and with that we can get IA, IB, and I1, which is 1.81, 2.83, and 0.037 amperes. So now we're going to find KCL at so it's going to be IA plus I1 minus I2. Yeah, so again, it's going to be IA plus I1 minus I2. So there we go. It goes inside, and outside. So we are since we already have IA, we also have I1. So the missing here is I2. So we're just simply going to transpose it and then substitute the values, add, and this is our I2. Now we're going to apply KCL at a node P. This one. Okay. So the current I1 goes outside, so it's negative. The current IB goes inside, that's positive, and current I3 goes outside, so that is negative. We already have I1 and we already have IB, so we're going to find I3. Transpose, same thing, substitute the values and then do the math, and we will get 2.793 amperes in I3. Okay. So with that, we now found all of the values of all the current. Okay. And we're going to continue to the next problem. Okay. In the next problem, we are asked to find to solve this circuit using the nodal analysis. Okay, so this is the circuit. Okay, again, assume in this part we are assuming a clockwise direction, and in this part we're assuming counterclockwise. Okay, so we are going to apply KCL at node A. This is node A. So in node A, IA is going inside A. So that is going to be positive. IB also goes inside A, so that's positive, and IL leaves A, so that is going to be negative. Now we're going to input the values. Okay, so in the node analysis, we are going to in the voltage part, we are going to determine the voltage using the voltage of the current in tail to tip. Okay, so where did our current start? It's in 12. Okay, and it goes into the node A, okay, which can also be called as VA. So that is 12 minus VA all over the resistance, because the formula of current is uh, I VR, V over R. So now again, this is the voltage and this is the resistance. Okay? Plus, yeah, because this is IA plus IB. Okay, this is IB. Again, this is our direction. So the current, it starts at 12 volts and then goes into VA. So 12 minus VA all over its resistance, which is 2. Okay, minus, because this is minus IL. So in IL, our current starts at VA. So it starts at VA and then it ends up in this node, which has no voltage. So it's 0 volts. So it's going to be VA minus 0 divided by its resistance, which is 8, is equal to 0. Okay, so we're going to simplify. Basically, this one is divided by 0.8, and also this one is divided by 0.8. Same thing here, 12 divided by 2, VA divided by 2, VA divided by 8, 0 divided by 8. Okay, so we are going to simplify these. That's going to be 15 minus VA 0.8 plus 6 minus VA divided by 2 minus VA divided by 8. Okay, now what we're going to do is first we're going to transpose these constants, okay, on the other side, okay, and then we are going to remove we are going to take all of the VA in the solution. Okay, so it's going to look like this. This is the VAs and these are the remaining values. So if you distribute the VAs, then it's going to look the same thing here without the 15 and 6. Okay, now we have this one. Now we're going to divide both sides by this value so that we can isolate VA. Okay, and then we have this one. So this is our VA. Okay, we're going to find the voltage drop. Okay, so 12 minus 11.2, that's going to be 0.8 volts. Okay, and our VL is also 11.2 volts. Now, using the formula of current, we can solve for IA, IB, and IL. Since we have the voltage and the resistance. So, the voltage, IA, the voltage is 0.8 divided by its resistance, which is also 0.8, so that is 1 ampere. IB, voltage 0.8 divided by its resistance, which is 2, so 0.4 amperes. And in the last one, IL is voltage, VL is 11.2 divided by its resistance, which is 8, so that is going to be 1.4 amperes. So that's all. Thank you very much.